usually got really famous back in the day when like CSIs and like the TV dramas, like for like crime scenes were coming out, because a lot of times you can use a DNA fingerprint to be able to like figure out like if like evidence matches a suspect. But basically what we're doing is we're just comparing DNA. Now the name of this process is called gel electrophoresis. The name actually is really, really descriptive because it tells us what's happening. So we have in this tray, we have a gel, like literally like a rubbery gel thing that's made out of a chemical that is called agarose. So agarose, it's, I don't know if you've ever eaten Jello cups. So it's kind of like that. Now what happens is on one end of this gel, we have these little tiny wells that they're like little cups that we can put our DNA samples into. And DNA as a molecule, it's charged negatively. And just like with magnets, opposites attract. So down here at this end, we have a positive electrical charge. So the DNA moves through the gel towards the positive end by running an electric current. Now, the DNA that we put in there, oftentimes it's fragments of DNA, and the small fragments are going to able to move through like the little tiny spaces in the gel really easy. Just kind of like a small person can fit through like a space in between these chairs really easy. But big fragments have a hard time passing through, and so they're going to stay closer to the top. So when you run the gel, you can actually separate the DNA based upon its size using that gel and the electricity. So that's why it's called gel electrophoresis. So this is what we know. So usually when you run a gel, you're going to have one lane. They call these lanes, kind of like, you ever watch people swim in the Olympics? Like you stay in your lane. So you're like, these are lanes. So in the first lane, we have like DNA that we know how big the fragments are, and we call that the ladder. And we can use that to compare, almost like a ruler, of how big these fragments are. So this pattern of DNA separation would be for a dog with furnishings that's heterozygous, has one dominant and one recessive allele. This lane has no furnishings. They only have recessive alleles. And then this third lane is showing us a dog with furnishings that only has dominant genes. So by using this as sort of like our key, we can interpret the 8 puppies to figure out like what they're gonna look like. And then we'll figure out like, is it Zeus or is it Otto? So let's start with this. So here's our ladder. So this first lane of DNA, which one is it more like? A, B, or C? So this one is a puppy with furnishings. What about this next one? So this is a furnishings but heterozygous. Okay. Another heterozygous. Another heterozygous. That's homozygous dominant. Another heterozygous one. There's a B, homozygous recessive. All right. So if this is the DNA patterns for our puppies, who's the daddy? Yep.
Beautiful, sir. That was well done.